is a horizontal asymptote, okay? So vertical asymptotes are going where? Up and down. Those come from those remaining domain restrictions, right? Horizontal go left to right, okay? We're going to actually start looking at what these look at on the graph after we go over horizontal asymptotes, okay? So, I crossed through the shear part. If you would like to see the horizontal asymptote shear, Miss Ophelia is down the hall. You can go ask her. I'm not going to do it. I'm not a shearer. I never was, never will be a shearer. I'm sorry. Maybe on the review day I might learn it. If I hear I'm not going to fail anymore, and I'll do the shear for you. How about that? Deal? Maybe. All right. So with horizontal asymptotes, what does it say after horizontal asymptotes? There's what? 3 rules to follow. So we're going to break this up into 3 sections. This one is a big one to remember. It's not hard, it's just remembering it, okay? All of these rules are just remembering. Can somebody read number 1 for me?
If the degree is greater than the numerator, there's no horizontal because you have a slant.
Okay, so if the degree, what does the degree mean? The highest exponent. So if the degree of the numerator is greater than the degree of the denominator, you have no, I'm going to call it a ha, but I'm saying horizontal asymptote. Okay? No ha. It means you have a slant. We're going to do slant next class, okay? No ha, you have a slant. So an example of this would be, what's the degree of that expression? What's the highest exponent? What's the degree? 2. What's the degree of the denominator? 1, right? This technically has a 1. The degree of the numerator is greater than the degree of the denominator, so that automatically means I have no horizontal asymptote. I have a slant. If you don't have a horizontal asymptote, you have a slant. If you have a slant, we're going to bring that all together in an example, okay? Second rule, somebody else read number 2 for me. Somebody else. I don't care who. Somebody read it. Good, go for it, Christoph.
If the degree of the numerator equals the degree of the denominator, and take the leading coefficient from the
Okay, so now if the degree of the numerator is equal to the degree of the what? Denominator? Your horizontal asymptote is going to be y equals leading coefficient over leading coefficient. And I'll show you what I mean by that, okay? So this time the degrees have to be the same. So if I'm a degree in the 2 in the top, I've got to be a degree of 2 in the bottom, okay? So if I have my degree in the top is what? 2. The degree in the bottom is 2 is equal to 2, right? So I'm setting the leading coefficient over the leading coefficient. The leading coefficient is the number at the very front, right? He's the leader. What's the number? I don't see a number here. Is it going to be 0? It's going to be 1, right? What's the leading coefficient of the other one?
3.
So the horizontal asymptote is at y equals 1/3.
Okay.
Leading coefficient over leading coefficient. What if I switched it? What if it was 3 and then 1? What would be my horizontal asymptote? Y equals what? 3. 3 over 1 is just 3. Okay? Now, what do you think the last rule is? If we've done greater equal, what's the only other thing to think about? Less than. Degree of the numerator is less than, I have to think about which direction. Remember, it makes an L. Yep. So that means I could switch the first example, right? I could do x plus 3 over x squared minus 1 or minus x plus 1. The degree of the numerator is what?
0.
Nope.
Oh, wait, no.
1. So it's 1 over 2. Is the numerator less than the denominator? So it is automatically going to be y equals 0. I don't care if that was 3 over 5, 4 over 7, nothing over 1. It would be 0 every time if the numerator is less than the denominator. Okay? Every single time. So does anybody see one that would give me a horizontal asymptote of y equals 0 where the numerator degree is less than the denominator?
6.
Number 6? Yeah. 1 is less than 2, right? So automatically your horizontal asymptote is going to be at y equals 0. Is there another one where the numerator is less than the denominator? I see one more. Can you find it?
3.
Number 3, right? This is 1 over 2, so automatically the horizontal asymptote is going to be at y equals 0. Now, do you see any that are none? Meaning the degree of the numerator is greater than the degree of the denominator. Raise your hand if you can find one.
4.
No horizontal, that means you have what we call a slant. We'll do that next time, okay? We're on information overload anyway. Anything else where the numerator is greater than the denominator? No, everything else is what? That's 1 over 1, that's 2 over 2, that's 2 over 2. They're all equal, so that means what? All their asymptotes are going to be y equals the leading coefficient over the leading coefficient of the numerator is what? Negative 2 over leading coefficient of number 2 is what? 1 over 2. So y equals write down number 5. What's the horizontal asymptote? Don't yell it out. Write down number 5. What would be the horizontal asymptote at number 5? Beat me to it. What do we get? Who's confident?
2.
Travis, what you got? Not 2 over 2. It's 2 over
1.
So what would it be though?
2.
Y equals 2. So remember, this is a line. Okay? Alright, the last thing we're going to do today, and I'm going to end the torture. I know this is boring. I'm sorry. Remember, I can't do backflips and make this very exciting. It is what it is kind of unit. Alright? I try to make it as best as I can, but it's just not as easy. Okay? I am going to walk through, so all I want you to do is look. Oops. This is on the back. If you want to write, because you just have to write to stay awake. This is on, it's labeled page 23. Obviously, there's not 23 pages, but this is in the back of that packet. We are looking at B. We are going to start labeling these parts, okay? We are not doing range. Yours should already be crossed out, but we are not doing range. Alright, so let's recap. Can we find domain? Do we know how to find it so far?
Yes.
Yeah, right? We have to find what first to do it. They've already factored it for me, so thank God, right? How do I find domain? What are my domain restrictions here? Let's go ahead and just list them. X cannot equal -2 and +2. So y'all go ahead and write the domain really quick. what would be the domain?
Wait, are we on page 24?
We're on this page.
Which one?
We're on B again. B on page 23, that really isn't page 23, it's just called page 23 because it's what I copied. You got it? You got it? You got thumbs up? Okay, so let's see if you got what I got. I've got negative infinity to negative 2 because negative 2 comes first from the left. Union, negative 2 to 2 because that's my second domain restriction, and then I would finish up with 2 to infinity. Raise your hand if you got what I got. Okay, pretty good. All right. What have we done next? What was our second characteristic? Because these aren't really in order how I want them to do or how they will be on your test. But what should come next? The whole. Do we have a whole, first off?
Yeah.
So we did this first, and then we're going to do this second. Do we have a whole? Yes. Its x value is going to be at what? Positive 2. I've got to write what's left over, which is I've got to plug in what for x? 2, right? This is just a review of what we've done. 3 times 2 is 6. 6 plus 1 is 7. 2 plus 2 is 4. So it is at the point 7 over 4. The domain I can't really put on my graph. But do you guys notice right here in yours, do you see that little break in the graph? You see that? That is at about 2, 7, 4. So we are going to literally put a hole there because that is where my hole is. This is what you're going to have to do on your test, is start labeling where these parts are. Okay? What was the third characteristic we did?
VA.
Not S, it's VA, right? Now, he is my remaining asymptote. I used 2 for my hole, so what's the only one left over? So my vertical asymptote is at x equals negative 2. That is this vertical line. Do you notice that the two functions are not crossing over it? They're both kind of veering off so they can't hit that wall. That is what a vertical asymptote looks like. It won't show up in your calculator. It's just a dotted line that is kind of invisible, but not really. What was our fourth one we did? We're going in order. X-intercept. How do we find x-intercept? Weird. It's like we just did it. I have deja vu. Set the numerator equal to 0 after I take out the what? The whole, right? So the numerator in this case is what? If I set 3x plus 1 equal to 0, I would subtract? Subtract 1 and then divide by what? So it's negative 1 over 3, comma, 0. Does that look like that? Because here's my x-axis, right? Is that where it looks like it crosses over the x-axis? Yeah, I would say so, right? You're going to have to estimate, but it looks about negative 1/3 if I had to guess. Before we get to the y-intercept, where do you think it is? Because it's crossing over right here. It's between 0 and 1. So a good estimate would probably be about what? 1/2, right? So the y-intercept is from, or the y-intercept is probably 1/2, but let's check. If I'm looking at the simplified, I'm just looking at the constants, right? Because I'm plugging in 0 for x. What's the only thing left over? 1 over. So my y-intercept is at 0, comma 1/2, right? So that was the fifth one we've done, and the sixth one was what? What did we just do? Horizontal asymptote. So he is number 6. Now let's look. Are my degrees equal? Are they one bigger than the other? What's happening? They're equal. So if they're equal, I set leading coefficient over. So y should equal what?